So warm-up 45, we found the measures of variation for 2, 7, 9, 5, and 12. And we found that the range was 10, standard deviation 3.81 using the shortcut formula, and variance was 14.5. Some of you did the long way. You got that for standard deviation and that for variance. All right, send me that to the screen, please. And here's the agenda. Warm-up number 45, measures of variation. And your home plate for tonight, page 143, number 7 through 10. 7 through 10. Or should I say 7 through 10 only? All right, thank you for sending that in. There's the agenda on your screen, and here's the code for your access to the home plate. 5YP2N, 5YP2N. And just a FYI BTW, in regards to late assignments, if there's anything that's late, remember it's going to count as partial credit, And the next progress report is coming up pretty soon, so don't fall behind. All right? And last night's, or the previous night's home play was this one. Yes? All right, go to Canvas, turn that in, please. Tonight's home play looks something like this. Let's go. And get a Cornell note ready, please. Give you guys some time to turn in your home play on Canvas and to get the Cornell note ready. All right, here we go. Our objective for today, I can summarize and compute the measures of variation. I can summarize and compute the measures of variation. Once again, I can summarize and compute the measures of variation. So by now, you should know the definition in your own words, right? Not what they are. We already know what they are. Definition in your own words. Talk it over your neighbor, please. Definition in your own words. No notes. All you. All right, type it on your screen, please. 20 seconds. In your own words, definition. Yeah, because if you have your peeps that they ask you, what are you guys covering? Oh, we're going through the measure of variation. What is that? Well, you should know. Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1. Thank you. Look up to the screen. We said that they were commonly used of what? Of variance, which means what? That the data varies how it's what? It's spread. That is correct. That's something to remember. All right. So far, so good. So, without the help of your neighbors, on your screen, fill in those blanks, please. See if you remember the different measures that we covered already and the last one where we're headed. See if you remember the measures that we covered already, including the, at the bottom, write the 3 for each of those. And the last measures that we're headed towards. Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1. Thank you. Should look something like this. Measures of central tendency, measures of variation, and where are we headed? Measures of position. So, once again, turn to your neighbor, let them know the measures of central tendency, the 3 of them. Let them know what the measures of variation are. All right. So, really quick, So far, up to right there, what we've covered so far with measures of central tendency, measures of variation from 1 to 5, how comfortable are you with what we covered so far? Where are we at? 4, 5, 4, 5, 23, all right? Yeah, some of you need to put in some practice. So, FYI, BTW. All right, so, formulas, where are we at? We are here. Oh, no, that's 11. And then the shortcut formulas. Is that correct? All right, turn to the back of your notebook. Make sure you have them. However, we are going to label them with their proper name. Is that correct? All right, just to make sure we know what we're looking at. This first one is what? Percent. And, of course, this one is degrees. All right. This one is the range, and this one is the width. All right, so far so good. This one is the sample mean. Sample mean. Tell your neighbor the name of this one right here. Tell your neighbor the name of this one. That is correct. Population mean. This one. Mid-range. Mid-range. All right. All right, tell your neighbor this one, and Jay's going to enlighten us with these two, the name of these two. Tell your neighbor the name of those two. See, as the ones we started with. All right. So, Jay, variance, but for what? Population. Population variance. That is correct. And this is population standard deviation. Thank you, Jay. So, guys, if this is for population, tell your neighbor the name of these two down here, the name of those two down there. Jay's going to pass it to someone. All right, Jay. Martin. Sample variance. That is correct. Let's go. How about this one? Sample standard deviation. And the reason I'm giving you the names, because you already did little cards yesterday, right? With a formula. So in the back, you're going to write the names so you can study them. Just FYI, I was giving you a heads up. And everybody say, thank you, JJ. Yeah, because I was going to give you a pop party today on the formulas, and he said that it was too soon. So we're moving it to Friday. Friday. All right? And the last two shortcut formulas, tell your neighbor the name of those. Martin, pass someone. Noah. Look at the symbol. Sample. Yeah, sample variance. Shortcuts. I even left it here. Shortcuts. And of course, this one is what? Sample standard deviation, bless you, shortcuts. Now you have all the names. Once again, you're going to label your papers that you made yesterday for the formulas. You can study those. Okay? Send me a picture that you wrote down the names. Oh, yeah. That you're taking copious notes. Very good. Appreciate it. And once again, thank you, JJ, for moving the pop party till Friday on formulas, because today we had more formulas. Let's go, JJ. Woo! got stuck here. These were the last two, right? The shortcut ones? Well, I want you to write this one down on the shortcuts. S equals R divided by 4. S equals R divided by 4. S equals R divided by 4. Now, by now, you should know the names of each of those symbols. I'll start with 4. The 4 means 4. Ooh-wee. Tell your neighbor what S stands for and what R stands for. Talk to your neighbor. What does S stand for and R stand for? All right. Noah, pass them one. Julius, what does S stand for? Sample, standard, deviation. All right. Yes, that's what the S stands for. Okay. So what does the R stand for, Julius? Range. That is correct. So this shortcut formula, guys, I'm going to label that in red. If you have red, that's fine. This is called the standard deviation. Standard deviation rule of thumb. Rule of thumb. So what is that, Mr. Q? It's kind of like this. Kind of like one rule of thumb that I keep conveying to all my students is to always be nice. Yes? That's a rule of thumb. That's something that you should take with you. If you didn't memorize any of the formulas, if you didn't learn any math in this class, one thing that you take with you is be nice. You know what I'm saying? So in statistics, in case you forgot, let's say you have those memory gaps. All of a sudden somebody asks you, how do you find the standard deviation? You're like, oh snap, I forgot. But I remember the rule of thumb. The rule of thumb to find the standard deviation is range divided by 4. All right. So let's see. Look up to the screen. So we covered this problem lookup with this data, and we did the long way. Is that correct? And we got standard deviation being 3.62. Yes? From there, I introduced the shortcut formulas, and then we did the same problem with a shortcut formula, and we ended up with a standard deviation of 3.62. Is that correct? All right, so example mega Q. Copy that data again. Example mega Q. And I want you to find me the standard deviation using rule of thumb. Rule of thumb formula. Find me standard deviation using rule of thumb. So just for the sake of time, you're writing the data. I'm writing the formula for you. And find me the standard deviation approximate. See what you get. Copy and go. Bless you. All right, looks like Jay's almost done with one set. Have you ever seen the rain? Oh, Miros. Okay. She comes back, just let her know. All right, 2 questions. Look up to the screen. Share with your neighbor what you got for the mean, number 1, and what are you going to divide by at the end for the variance, n or n minus 1? Tell your neighbor yn or yn minus 1. Which one are you going to divide by for the variance, n or n minus 1? Because you need the variance for the standard deviation, right? Yes, Mr. Q. All right, looks like Alyssa's got it. Very good, Alyssa. Sophia's got it. I see you, Sophia. Of course, Selena's got it. All right. But let's go with Cassandra. Divide by n or n minus 1. N, that is correct. We're going to divide by capital N. Tell your neighbor why. Is it obvious? Yes? All right, pass someone, Cassandra. Matthew, why N? Right, because they mentioned here, consider both small, what? Populations, not samples. Using what? Population. Therefore, your formula should have been variance equals x minus mu squared divided by n. Is that correct? Or your process. You found the mean first, subtracted from all the data, then squared it, and at the end you divide by n. All right? So you still are finding me what? Standard deviation after that, which is just the same formula, square root. Is that correct? Yes, Mr. Q. That's why I gave you the names, because this is what? Population. All right, you should be almost done. And I'm going to sketch my bell curve, and I'll have somebody get me started with this on this side. And then I need over here my variance for this side and my standard deviation as well. One more minute, and then I'll have you share with your neighbors, so like that we can get this show on the road. All right, looks like Donna's got it. Very good, Donna. Of course, Vanessa's got it. Very good, Vanessa. All right, for the first data, we need a mu. Matthew, pass them one. JJ, what do you get for the mean for the first set of data? 35. Hands if you got 35? Looks about right. So I'll wait for a standard deviation, 1 up, 1 down. And why am I looking at this section only? Because this is the what? Remind your neighbor. This is the what? Remind your neighbor. From here to here? Yes, the norm. All right. JJ, pass someone. Standard deviation. AJ, what'd you get? 14 point what? 14.2. Hands if you got something like that? Did you use the long way? Or did you use a shortcut? Okay. Hands if you got something different. Trinity, what'd you get? 17. Approximately 17.07. Hands if you got 17.07. Looks about right. That one's a little bit closer. So check your work, AJ, with that. So if we go up, we should be at 52.07. And one below, we should be at 17.93. So once again, this is our what? Our norm. So now let me pause the music in the background and look up. 17.93 all the way to 52.07. These are what? Months, right? All right. So look at these data, just with the brand A. Tell your neighbor what would be a conclusion for brand A with that bell curve right there. What would be your conclusion for brand A only? Brand A. All right. Trinity, pass someone. Me? Let's go, and I'm going to pass it to, who haven't we called on in a while? How about Anthony E? Anthony E. So the norm is 17.93 months to 52.07 months of fading before they start fading. What can you conclude for brand A? There's 6 buckets, 6 of them. That's 2. Martin. All right, help them out. How about Alyssa? What can you conclude for brand A? Most, how many, to be exact? 4, which ones? 50, 30, 40, and 20. Hands, do you agree with that observation? That is correct. All these fall within the norm. The only ones that are not in the norm are 10 and 60, but that's just for that brand. So by now you should be done with the variance and standard deviation for the second brand. Am I right? Am I right? Yes, Mr. Q. All right, good. And once again, we're just looking at one standard deviation because this is our what? Our norm. All right? We good? Looks like A just got it. But let's go with Nick. We haven't called on Nick in a while. Nick, what'd you get for the variance for the second brand? Yeah. 25. And for standard deviation? 5. Hands, if you got something like that, looks about right. That is correct. So 25 for the mean, my bad, for the variance, but now I need the mean. What you get for the mean, Nick? For the second brand? 35, also as well, yes? All right, so standard deviation up, we are at 40. Standard deviation down, we are at 30. So that means in months, it's from 30 to 40 months, yes? So, conclusion for brand B. Tell your neighbor, what do you see for brand B in regards to being a conclusion? Talk to your neighbor. What do you see for brand B, a conclusion? All right, Nick, pass someone. You said Martin. What do you see? If the norm is from 30 to 40 months, and these are the 6 buckets, what can you conclude? Which ones fall within the norm? 30, okay. What else? Yes. 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 Is that it? Yeah, right? So again, those fall within the norm. Okay. So, now comparing both bell curves. These 4 fell in the norm. These 4 fell in the norm. Do you see anything that you want to bring up as a conclusion for both brands? Talk to your neighbor. Come up with a conclusion for both brands. Conclusion for both brands. All right. Looks like Jessica's got it. Very good, Jessica. Mito's got it. Very good, Mitos. All right. So once again, the context is this. A testing lab wishes to test 2 experimental brands of outdoor paint to see how long each will last before fading. The testing lab takes 6 gallons of each, there they are, and gives the data in months before fading. All right. Any observations? Let's see. Go with Rianne. An observation. Which one? Brand A. Brand A of paint has a larger range of time before fading. Hands, if you agree with that observation? Yeah, that is correct. Just by looking at the numbers, notice that most of these numbers are in the high end of the bell curve. All right? I'll stop right there. From 1 to 5, how comfortable are you comparing 2 sets of data? That's 3 4s, 5s, 5 4s. Okay. Now, the only thing, guys, that I think you guys are getting a little bit webbed up in your noodle is this. I gave you this type of numbers in the warm-ups, didn't I? The only thing I didn't give you the words, I just gave you numbers. Did you find any standard deviation? Yes. Did you sketch a bell curve? Yes. So what's the only difference this time? The only difference is that you need to pay attention, look up. If you're going to use at the end, is it a population or is it a sample in order to divide for the variance by n or by n minus 1? Are you following? All right. So, with that said, send that in, please, to your screen. Now, the home plate for tonight is these four problems. Number 7 is straightforward because it's only one set of data. Same thing for 8 and 9. But look at for 10. For 10, they give you two sets of data, which is similar to the one we just did. That's why I wanted to get through that one. All right? So I'm going to give you a head start. There they are. I'm going to stop the video right here. For those of you that are following on YouTube, get some practice in, and I'll see you guys next time. I forgot right here in the formula, guys, to write the sigma for the sum for both. Sorry. There they are.